Hi guys, today we'll start with the last concept in a vector algebra, that is a vector or a cross product of two vectors. So as I said that, product of a two vector, we have two cases. One is a dot product, another one is a cross product. Dot product is nothing but it is a scalar product. The resultant of a scalar product is nothing but dot product. Will get a scalar only. So again, in a vector or a cross product, the result of the vector or a cross product of a two vector, the resultant will be vector itself. Is nothing but there will be ijk component. Now if I take two non-zero vectors a and b, vector a and vector b is denoted by a cross b and is defined as vector a cross vector b as magnitude of vector a into magnitude of vector b into sine theta into n cap. So here I'll just take one figure. So this make it as a unit vector n cap. I'll just take this is a negative n cap. This is a vector b. This is a vector a. In between it makes as an angle theta and it is anti-clockwise direction. Okay. So here is where theta is an angle between a and b and n cap is a unit vector perpendicular to both a and b, such that a, b, n cap form a right-handed system. Okay, the right-handed system rotated from a to b moves in the direction of n cap. Is it clear? If either a is 0, either b is 0, then theta is not defined in this case. Is it clear? If a is 0 or vector b is 0, then theta is not defined, because theta is an angle between a and b. If any one is 0, then we can't define the angle, that is theta. We can write that as vector a cross vector b is 0. So now with the help of this definition, we have some observations. Those are observations. So first one, vector a cross b. If you do it, the cross product of two vector is, the result is again a vector. This is the first observation. Then the second is, if vector a cross b is 0, if and only if vector a and vector b are parallel to each other, or sometimes we'll call it that is a collinear. In a cross product, if they ask prove that a and b are a collinear, is nothing but you need to do it a cross product. If you get the value is 0, then you can say that these two are collinear, or you can say that these two vectors are parallel to each other. Is nothing but vector a cross vector b is 0 if and only if vector a is parallel to vector b. Is it clear? This is the second observation. Next is, if I take I, j, k are mutually perpendicular to unit vectors, you can take I cross I is equal to j cross j is equal to k cross k is equal to 0. Don't confuse with a dot and a cross. In a dot, this value will be a 1. In a cross, this value is a 0. Now, I cross j, you can take it as a k. Then j cross k, you can take it as a I. Then k cross I is equal to j. Is it clear? So which is like a cyclic? I, j and a k. So if you take it a cross product, I cross j, and that is equal to k, j cross k, that is equal to I, then k cross I, that is equal to j. Is it clear? So now this vector product is not a commutative, because if you take, it is a reverse. If I write j cross I, you can write it as minus k, because it is in the opposite direction, right? J and I, that is equal to k, but it is a negative. It is in opposite direction, therefore it will be negative sign. It's nothing but this vector product is not a commutative. Vector A cross vector B is equal to minus vector B cross vector A. It is not a commutative. Now how to find the angle between two vectors is nothing but it is a sine theta is equal to magnitude of vector A cross vector B divided by magnitude of vector A into magnitude of vector B. That means you need to do it cross product. Again, for that vector you need to take a magnitude divided by magnitude of each vector. There you will get the angle between two vectors. Is it clear? So next is that is the sixth one. If I take vector A and vector B are represent adjoint sides of a triangle. So adjacent sides of a triangle. Then you can write this as half of magnitude of vector A cross vector B. Okay. Next is they may ask a parallelogram. Is nothing but again vector A and vector B are represent adjacent sides of parallelogram. Then the area of parallelogram will be, it is a magnitude of vector A cross vector B. These two are important. For a 2 mark they may ask. They'll give two vectors and they'll mention it, these two vectors are adjacent side of a triangle. Then find the area of a triangle they'll ask. Is nothing but you need to find the cross product, take a magnitude, then divide it by 2. There you will get the area of a triangle with the help of cross product. Next they'll give you two vectors. Those two are adjacent sides of a parallelogram. Then area of parallelogram will be, which is a cross product of two vectors. Then you need to take a magnitude of that. So these are the observations based on the vector or a cross product of two vectors. Okay. So now we'll just solve the problems based on these observations, and that will complete your vector algebra chapter. So I'll just go with the examples. So first one, find a magnitude of vector A cross B if vector A is 2i plus j plus 3k and B is 3i plus 5j minus 2k. So now what you will do is, first we need to find the cross product of this. So how you will find the cross product is nothing but, I didn't mention the definition, right? So here is, you should always write like, so first row as I, j and a k. First row you have to write like a determinant. First row is ijk. Second row is a coefficient of ijk in vector A. And a third row is coefficient of ijk in a vector B. So this is the definition of vector A cross B. Okay, is nothing but in a vector A, coefficient of I is a 2, coefficient of j is a 1, k is a 3. Next B is a 3, then 5 minus 2. Hope you guys remember how to find the determinant. It's nothing but First row, first element is a I. You just delete it first row and a first column. Remaining is these 4. You just multiply the diagonals. 1 into minus 2 is minus 2. In between you should use minus. 3 into 5 is 15. Next, for a second element you need to take negative. Minus j. First row, second column I did. 2 into minus 2 is minus 4. Minus 3 into 3 is a 9. Then plus k. First row, last column. 5 into 2 is a 10. Minus 3 into 1 is a 3. So here is the I. Minus 17. Next is minus j into minus 13 plus k into 7. We can write this as minus 17i minus into minus plus 13j plus 7k. So this is what vector A cross B. So find A cross B means you have to do it like this only for all the problems. So this is what the definition for a cross product. Determinant, first row always ijk, second row is the coefficient of ijk in vector A, third row is the coefficient of ijk of a vector B. Okay. Next, here we need to find even magnitude also. Once you will get the cross product, so as I said that the result of a cross product is again a vector. Vector is nothing but there will be ijk component. So now magnitude of vector A cross vector B is equal to square root of coefficient of I is nothing but minus 17 square plus 13 square plus 7 square. We can write this as 17 square is 289. 13 square is nothing but 3 3 is 9, 3 and a 1, which is a 169. 7 square is 49. Okay, so 3, 4 and 5. As the sum of these three terms is 507. So this is the magnitude of cross product of given two vectors. Okay, so hope you guys understood this one. So you just look up with a definition and the observations, then this one example. So we'll do the remaining example as well as the exercise in the next class. So that will complete your chapter vector algebra. Okay, thank you guys.